Today we're going to be finding particular solutions using initial conditions. So we're still going to have differential equations that we're going to need to solve. But in the end, we're going to figure out what C is equal to. So for example 1, the general solution to the differential equation dy over dx is x over y. Equals x over y is y equals positive or negative square root of x squared plus c. We're going to let y equal f of x be the particular solution to the differential equation with the initial condition that f of 5 is equal to negative 4. Okay. So when we're doing these particular solutions, if the ones that have plus or minus is only going to be one or the other. All right, so to figure out if it's positive versus negative, you look at the initial condition. Because the initial condition's y value is negative, this one we're only going to have the negative square root. Okay. All right, and then once we get that, we're going to plug in the initial condition. Okay, so for y, I'm going to put in negative 4, and then for x, I'm going to put in 5. All right, and what we want to get from this is what c equals. Right, so I would go ahead and square both sides. When I square negative, we get a positive, and then when I square root, it cancels out. So we're left with what's underneath, which is 25 plus c. So that means that c must equal negative 9. So I'll just take that negative 9 and plug it in there. So y should be equal to, or we'll call it net f of x, because it tells us to find f of x. So f of x is equal to negative square root of x squared minus 9. That's the equation that has this derivative and has the initial condition of f of 5 equals this one. We're going to do that, but we also have to do the stuff that we did yesterday. So for example 2, we're going to find the solution of the differential equation dy dx equals y to the second with initial condition of y of 1 is 1. All right. So the first thing we would want to do is separate the variables. So we move the y's to one side and the x's to the other by dividing by y squared and multiplying by dx. Right. Then I would rewrite dy over y squared as y to the negative 2 dy. And now I'm ready to integrate, where I will add 1 to the exponent and then divide by my new exponent. Right, and then the integral of dx is just going to be x plus c. Okay, I'm going to do one more step, and we're going to put in the initial condition really early. So negative y to negative 1 is negative 1 over y. And then we're ready to plug in the initial condition, which is when x is 1, y is 1. All right, so we're going to end up with c is equal to -2. So we'll just take that -2 and plug it in right there. So -1 over y should be equal to x minus 2. Alright, so we can write that x minus 2 as x minus 2 over 1. And as long as we have one fraction equals one fraction, we can do the reciprocals are also equal. Right, and then we'll just multiply those ones together, -1 times 1. Okay, that is the solution. Okay. And then on this last one, the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at time t days after it is first weighed, then dv dt equals 1/5 times the quantity 100 minus b. Use the separation of variables to find y equals b of t, which is the particular solution to the differential equation with initial condition b of 0 equals 20. So they give you a whole bunch of stuff you don't need. Like they give you in the words what the initial condition is, but then they give it to you again. They give you in the words about how the proportional weight is, but then they give you the differential equation. So really, we could have started the problem right here. So what we'll do first is separate the variables. So I would divide by 100 minus b and multiply by dt. Then I'm ready to integrate both sides. Now this left side, if that had just been dv over d, then I know it's the integral is the natural log of the absolute value of b plus c. But I have an expression down here, and that expression does not have a derivative of 1. So I'm going to do u substitution. Now as we do these, you may kind of figure out a shortcut, but I'm going to do it the long way. So u is going to be the 100 minus b. The derivative of that is -1. So du is equal to negative dv, or -1 times dv. So I have the dv, but what I need is negative dv. So that means I would also need a negative in the front of that integral. Alright, so now I would go ahead and rewrite it using u. So in the place of negative dv, I'm going to put du. In the place of 100 minus b, I'm going to put u. And I'm going to hold off. I'm not going to find this integral yet. I'm going to do them at the same time, so I just don't get confused. Okay, so now I can integrate. So the integral of du over u is going to be the natural log of the absolute value of u, and that negative drops down. And here, this is going to be 1/5 t plus c. Now on these, the ones that have, oh, we're not quite ready yet, but the ones that have the natural log, we're going to wait a while to plug in c. All the rest of them, we plug in c super early, like almost as early as you have a c, you're basically putting in the initial condition and finding c. On these with the natural log, I think it works out easier if we just hold on a second. So we're going to keep that c for a while. So I went ahead and I put u back in as 100 minus b. Okay, and then I don't want this negative, so I'm going to kind of divide through by a negative. it's a different constant. And then I know to get rid of a natural log, I'm going to exponentiate. Okay. And then that will drop off, and I'm left with the absolute value of 100 minus b is equal to, and then just like we did yesterday, I could break this apart as e to the negative 150 times e to the c sub 1, and then have that new c in the front. Okay, so now I'm ready to plug in initial condition. All right, and our initial condition t is 0 and b is 20. Okay. So that's going to give me 80. And then e to the 0 is 1, so c sub 2 is 80. Right, so I'm ready to plug it back in, or plug it in there. Let's talk about these absolute value bars for a second. Now, b is the weight of a baby bird, and 100 grams is the adult weight. So that baby bird is never going to weigh more than it will as an adult. So the absolute value at this point really isn't necessary. So we can drop it off and just have 100 minus b, and then put in our 80 for the C2. So I'm just putting in the 80 for the C2. And then to solve this for b, I am going to move b over to the right, and it's going to become positive. And I'll move the 80 e over to the left. So e of t should be equal to 100 minus 80 e to the negative 150. And that's your answer. Now, lots and lots of people want to subtract 100 minus 80. But you can't, because that 80 has that e attached to it, so that e and the t, they're not like terms. So this is as far as you can go. So this will give you the weight of the bird t days after its first weigh. All right, so your assignment is to do the back side of that worksheet, of the note sheet, which is topic 7.7 worksheet on a separate sheet of paper. Obviously, there's no room to do it on that.